Hello everyone, welcome to this day 4 of the C Programming Bootcamp. So before I start, let me remind you that there will be a Google form which will be posted in the live chat at the end of the session. Please don't forget to fill the form for attendance. So let me tell you what we are going to cover today. We are going to cover the arrays, like arrays is a data structure, and it is a how we are going to search a particular number or search a particular character and how to sort the elements. So that is what you're going to learn today. And let me start. What is an array? An array is a variable that can store multiple values. An array is defined as a collection of similar data types stored at contiguous memory locations. So, so let me tell you that whatever number we have stored till now, we have stored with a particular letter, right? We have stored like a equal to 10, a equal to 15, a equal to 20, a equal to 100, and so on. We have given a particular letter, and how many with that particular thing I can show you till Z, right? A to Z, and again with capital letters it will be different from capital A to capital Z. So we are able to store only one particular number in one particular letter, and in the same way we are able to store one particular alphabet with another alphabet. So why can't we store more than one number or one character in one particular alphabet? So then they thought of something known as an array. Now this is an array. Array is a data structure, right? So it can store multiple values. You have understood this statement very well. Now coming to the next part. Whenever in an examinations or whenever someone is asking you what is an array, this is the definition you need to give. Right? Collection of type of data items. Similar data type of data items is nothing but the data types. Now you know about the data types, right? Now data types are nothing but int, long, float, character, and there are many, right? So unsigned int, signed int, and the list goes on. So anyway, when you're storing up numbers in an array, it should belong to the same data type. Means all should belong to int, all should belong to char, all should belong to long, float, short, int, whatever it is, right? So to the at contiguous memory locations means at continuous memory location. We call it as contiguous memory locations. So anywhere. Now, what is this contiguous memory location? Let's assume there is a box. Okay, box is nothing but the memory in your uh, computer, memory in your personal computer or in a laptop. So, whenever we are storing a particular number, whenever we want to store a equal to 10, then what will happen is int a equal to 10, it will, when int is 4, let's assume, as I said you on the day one, that every data type there is one particular memory according to the system, right? So let's assume int is, usually we call it as 4. Okay, in most of the systems it is 4, so we call it as 4. So when we say that int a equal to 10, it is going to allot space, four bit space in the box. Okay, box is nothing but the memory. So when it is going to store like that, it is first going to search where is there a 4 bits of space, means 4 units of space in that particular box, and then it is going to store in any integer. Whenever it is going to store, that is going to happen. Now if you want to see that part, you can actually press on, when you're pressing in printf statement, you can actually print ampersand a and ampersand b. When you're going to press ampersand a and ampersand b, percent d, ampersand a and ampersand b after the comma in the printf statement, you're going to see where the particular a is being stored, the number that is given to the a, the number that is given to the b, not the binary values, the number that is given. Means, let's assume the box is made into spaces, each space is given a number, that number you will be able to see. Right. So you have understood that particular part. Now, when we say continuous memory locations, an array has continuous memory locations. For example, now we are storing a set of numbers from 1 to 5. Okay. Here I am going to write 1, here 2, here 3, here 4, here 5. Means, let me take a pen and show it to you. 1, 2, 3, 4, and 5. Right. So when we are going to write it like this, first we are going to assign it to a letter. So let the letter be capital A. Now as it is an array and I want to write it like this, it is an array, right? So so this will be, let's assume it is starting from 1000. Okay. Now this will be 1000. Now as it is an integer, integer will have four bit space, right? So integer 1004, right? Now 1004 will be this one, 1005 will be in this, 1006 will be in this, 1007 will be in this, and 1008 will be given to this particular space. Okay. Now the difference between that particular character and this is that it has continuous memory locations. Means it is given as four locations. Now again this is given as 4 bits. Now after 4 bits, it is given to this number only. Whenever there is space, only this array can be taken place. Now again 1008 here, 1009 here, 2010 in that particular place. Okay, in two for two itself it is going to play allot that space. Now again for this 1012. Okay, 1012, and just writing for the last two digits here. Now again 1016 here. Okay, 1016 and 1020. So this is how the continuous memory location mean. Right. Arrays are the derived data type. Now I have said you about the primary data types and the derived data types in the day one itself. The primary data types are nothing but the data types which are the basic simple data types. Now see here, the examples of the primary data types are given here. Char, double float, etc. Now I have not focused on that particular derived data types on the day one because it is a little hard to understand. Now you have understood the primitive data types. The derived data types are nothing but taken from these particular data types only, we have made some other data types. Now there are arrays, now there are strings. Now strings is nothing but if there is a character array. If it is a character array, then it is a string. Now, what is a character array? When we are storing a set of alphabets, we are going to see it as character array. So when we are going to store particular set of characters, that is nothing but words. So means what I'm trying to tell you is that set of letters is nothing but words, right? So whenever we want to store words, we are going to use string. String is nothing but character array. We have understood it very well. Now let's go to the next slide. So what is an array? Array in C. Now this is nothing but the syntax part. So the syntax part is nothing but this is an array, right? Now this we have defined something. Okay, we have defined something known as an array. Array you have understood now. With the first three letters of the word array, A-double-R-A-Y, we have defined a particular variable which has, okay, we need to understand that array elements start from zero. Now, for every, in an array, again, there will be something known as indexing. In an index, in a particular record, when we are writing a record, what is an index? For every content part, for every title, we are going to give a particular number. In the same way, in an array also, for everything, for every box, you can say it as a box or every element, there will be given a number, and that number will start from zero. That is the most important part in any data structure. Most of the data structures start from zero itself, and in array also it starts from zero, right? So it starts from zero. So whenever we are writing a particular element, that particular index number, we are going to recognize this particular box. Right. When we want to recognize the number in this. So for in the previous example, I have written 2. So how are you going to take the number 2? We are going to give it as array of 1008. That particular number will be given. Now this is about the locations, right? Sorry. Again, the number will be given. That number will start from 0, as I said to you. That number will be start from 0. This will be 1. This will be 2. This will be 2. And this will be 3. And this will be 4. Right. So you have understood this part. Now this is nothing but the indexing part. Now if you want to access the second element, you are going to give it as a double r of 1, a double r of 2, a double r of 3, a double r of 4 for this element. Right. So you have understood this part. The next slide. So you can do array declaration in any way. So int array of 3, int array of 3, 1, 2, 3, you can write it like this. you can write int array of 111 means I'm showing you the examples over here. These are not the types. Now int array of, if you give zeros, I mean you can leave it as null, means we are not writing as anything, then it is going to consider as zeros. Okay, when you have declared an array and we have not given any values over there, it means it is going to consider as zeros in all the parts which is given. Right. So if you write 0, even if you write 0, it has the main thing. Okay, when you write it like this, the first element is going to be 1, the second element is going to be 0, the third element is going to be 0. Now you can try all these parts. You can try all this part and this part also in the programs, and you can try. Now what you're going to do, I have said you how to access the element. When you have understood how to access the element, you are just going to write it in the printf statement, %d, comma, uh, ARR of those square brackets, and we are going to write the element number. Right. Element number is nothing but the index number. That index number, if you write it, you can understand these part. So try them. Don't forget to. I mean, whenever someone asks you a question, what if you write it like this? Will it be? Will there will be no elements, or will there be element zero in all the parts? So when someone asks you questions like that, you will be able to answer the question. You will be able to answer the question. Only if you practice, you will be able to remember, or else you might forget after a particular point of time. So two-dimensional array. So before I teach you the two-dimensional array, I want to show you an example of the array declaration in C program. So So before I tell you about that particular, okay, let me say about this as the last part. Anyway, I'm going to open a new file, right? Source file, source file. Now I'm going to show you basic array program, and then hash include and then int main, then again int. Now I'm going to define an array, right? Array has now, okay, I'm giving the word as A. Now, A double R. So here I'm going to take it as just A. Okay, just A. I can give any, I can define it with anything, right? So this square brackets are going to be used for an array. You need to remember that part. So in the place, in the brackets, you are going to write the number of places allotted to that particular array. Now, number of places, number of elements. So let me take the number of elements to be 15. So 15, and I want the elements to be, now we are going, when we are going to write the elements, we are going to use the curly braces. Right? The curly braces. The curly braces, now the elements are, I have wrote, instead of 15 elements, I'm just going to write 5 elements. Right. So let me take the elements as 1, 2, 3, 3, comma 4, comma 5. So you have understood these are the 5 elements. I'm just going to print the each element. Right. Printf %d. Now, why have I written int? Now the array data type, the array that I'm going to define consists of integers. So I'm going to write it as an int. If I write it as character, that is going to define it like that. So print %d. Now I'm going to write it as um, a double r. Okay, a of 0. Now when I write a of 0, 1 should be printed. Let's see if 1 is printing or not. So control S. The program should be saved in day 4. Now in the day 4, array program. So it is a .c file. It is saved. Done. I'm compiling it and running it. Now let's see if 1 is printing or not. Okay, it's not print, I'm sorry, it's printf. Right. I saved it, compiling it and running it. Now let's see if 1 is printing. If 1 is printing, the index of this element is nothing but 0. So that is what you need to understand. See, 1 is printing. Right. Now once you have understood this part, let's go to the next part. I'm going to print the address. Now where it is storing is nothing but the address. So I'm going to print that part. Ampersand A of 0. whenever you're going to define for a particular, now let us write a equal to 5, even in that particular case, you can try and know the address of that particular part. So I've saved it. Now I'm going to compile and run it. See, that is the address. Now let me take the integer 2. Okay, that should be 6. Last digit should be 6 because it has four things, right? So again, I'm going to write printf statement %d ampersand a of 1 means the second element. The second element consists of 2, right? So, so you have understood this part. I'm saving it, right? Zero errors and zero warnings. Okay, let me print this in a new line. I have saved it. See, as you have understood, it is something known as okay. It is 64,87,552. This is nothing but 64,87,556. Means for this particular number itself, for the number one itself, it is storing 4. And again for this, the number, whatever the number that is storing here, where is it? 64,87,000, right? 64,87,552 and 64,87,553, 64,87,554 and 64,87,555 is given this 4 bits. Now each is a bit, right? So these 4 bits are given to this, and the next 4 bits are nothing but, that is the reason it is given here 556. 556 to the number goes on. It is again 66,87,560. Okay, so not 560, 559. Okay, 56, 57, 58, 59, 4. And again, if you print for the next elements, it will be 60. From again 60, it will be starting. You can try the address. Now this is the basic array program. Now you can store any number of elements, right? You can store any number of elements, you can print the elements, you can print the address like this. So you can try various things on this, and I would recommend you to try. It should print using loops only. You can do it should print the maximum element and the minimum element in the array. I request you to try this program. So after you try that program, we are going to discuss about we are going to discuss. Okay, so pause this and try to do that program. So array declaration in C. So you have understood this array declaration. So the next thing that we're going to learn is the two-dimensional array. So this is a nothing but a two-dimensional array. Now two-dimensional array, this is how we are going to define. We are going to write it as two brackets, two box brackets or two square brackets. Now if it should have three, first we are going to give it for rows. The second one is for columns. Now it should has 4 columns. Then we are going to write 4 columns. 4 columns will be there and 3 rows will be there. Okay. Now X is nothing but the name of the array, and float is nothing but the data type. You have understood this part. Semicolon, you know it. So now, as you know, you might have learned matrices in your lower classes. Now you can store the matrices in this particular two-dimensional array. So the x, now each one will have a particular number. That particular number will be given as x00, means now that is the row 0 and column 0. You might have learned for matrices before. This is the same way how you're going to write it for two-dimensional arrays. Now there are other uses where you're going to use two-dimensional arrays, but you have learned this particular matrices. It will be very easy to understand. So row 1, so it is row 1 here. So it is column 0. Now again row 2, so it is 2 here. It is 2 here and column 0. Now again x is 0 means it is row 0, right? So column 1. So here also you need to understand that the rows and the columns start from 0 itself. Just like in the previous place, where it starts from zero. Right? In the same way, the rows and the column numbers also start from zero. So it is row one, column one, row two, column one, and here it is row zero, column two, and here it is row one, column two. Here it is row two, column two. So you can do this part. You have understood this part. The best example is a matrix. Right. This is column 0, column 1, column 2. Now these are rows. Rows and columns you might have understood by now. Now this is how a one-dimensional array looks inside the computer. Okay. Inside the computer, this is a data structure, how this looks. Now I have shown you how to write it in a program. This is how it looks. Now uh, whenever we want to give a set of numbers as an array, we define it in the box. Okay, we show it in the box. Whenever we want to show a two-dimensional array, we show it in a table like this, which consists of rows and columns. Right. So I'm going to show you an example for the two-dimensional arrays. Control Alt Tab. So yes, source file, two-dimensional 2D array, hash include stdio.h, int main, and again this curly braces, and now we are going to write it as int. Right. Now you can try for the string and everything. Now I'm going to say about the string in the last part anyway. So string of rows and columns. Let me take the rows and columns as so here let me take 3 and 4 elements so that if it is less number it is easy to understand. Okay, now how are we going to define the elements? Now defining the elements we are going to write it like this. Okay, we can do it in two ways. Now I will take the first easy way so that 8, 16, 9, 52. Okay, after 52, now here you need to understand that these 3 is nothing but the number of rows. 4 is nothing but the number of columns. So if there are 4 columns are completed. So here I am going to print a new line, enter. Now without entering the new line also, that is the second method I am trying to say. Now without going to the new line answer, we can press it. Now 3, 3, 15, 27 and 6. And again, here I'm going to take it as 14, 25 and 2, comma 10. Now without writing this also you can do. Now I'm just going to print the array. Printf first in the a of 3 and 3 and 4. So save it to the array. So it is a .c file and save. Alright. Then this is done. Okay, now you need to understand that this is a very common mistake. I have shown you a very common mistake. What many people do. We shouldn't print a statement like this. We shouldn't write the statement like this. When we are okay in a normal array, we can write it like this, where it can print the whole array. Right. Now in the normal array, we can do that. But okay, in the normal array also, how we are going to print the whole array? We are going to write a loop for. Okay, we need to define another integer. We can write another integer over here. I, right. For I equal to 0, right. The application of arrays I'm going to show you. The application of the loops I'm going to show you. I is less than 5 and I plus plus, right? So printf %d, right? It should print a of I. So what I'm trying to tell you here is first the I value is 0. So the element of A0 will be printed over here. Means 1 will be printed. Again, element of 2 will be printed. Element of 3 will be printed. Element of 4 and element of 5. So it is less than 5, right? So it will go till I equal to 4. So I equal to 4, the 5 elements will be printed. So that is how we are going to print the particular elements, print array elements. So, okay, I want to print it in a new line. See, each element is printing in a new line. These both are addresses that I said you before. 1, 2, 3, 4, 5. This is how you are going to write the elements. So here, when you are going to write it for two-dimensional arrays, you are going to print it in this particular format. Printf. Okay, first we need to write the loop, right? So for I, so if we need to write I, we are going to write it again I here. Now when we are writing a comma and we are writing an I, we need to understand that I also defines to the I also is a data type of int. So we can write it like this. Or many people write it like this also again. This is nothing but a new part. Okay, nothing but I mean this is not a new part. So int I, we can write it like this also. Or we can instead of writing I and T in a new line, we can write it like this also. We can write a comma and place it over there. So when we are going to print the values, okay. So whenever we are going to print the values, we are going to use the nested loops over here. So it is very interesting, I feel. So I is less than how many elements will be there? Number of rows. The number of rows is nothing but 3, right? Yeah, anyways, it should start from 0, 0, 1, 2. So it should always be less than 3. And I plus plus. So this is how we are going to write. And again, inner loop, right? So for I, j equal to 0. Now the number of columns are 4. So j less than 4. And as it starts from 0. And again, j plus plus. So here inside we are going to write printf, right? Printf %d %d, and then we are going to write the matrix. Matrix is nothing but int a. So a of, so the element is I comma j. I j element should be printed. And the next thing that you need to understand that after printing the ij element, right? After I values, there should be, I mean, there are the rows, right? After every row, we are printing an enter. So that particular printf should be printed in a new line. So only for the I loop, I am writing printf. It should print a new line. So you have understood this part. So again here, yes, I've saved it. Compile and run. Okay, I have not see. We have got an error that j is undeclared. So we need to write int I comma j here. Right. I have defined two integers. I have defined, yeah. See 8, 16, 9, comma 52, 3, comma 15, 26, 6, 14, 25, 2, comma 10. So instead, what I'm going to do is I'm going to press a comma here. So that after every element, a comma will be printed so that it is easy to access. So what we need to see after every element, comma is being printed so that we can easily differentiate the elements. See, however I want, I'm printing it. So if you want to print it after every element, you want it with a dot. After every element, you want it with a semicolon or a colon. You can all do the parts according to the requirement. So that is nothing but coding. Right. However the client wants, however the user wants, you are going to prepare a model for it. So this is a two-dimensional matrix. Now coming to the searching and the sorting techniques. to find an element to check whether the element is present or not in the array. So now I will tell you about the elements from 1 to 5. Now there are infinite number of elements you can define in an array. Now how do you search for a particular element? So searching for particular elements, there are some techniques that we are going to learn today. So before I say you about the searching technique, let me tell you whatever I want to find in a particular document. I I find I mean I find the option for finding it, and then I'm going to search for that particular word or particular number. Now, how is that going to happen with these searching techniques? Now, there are two kinds of search. There are two kinds of searching techniques that we are going to learn for. We are going to learn today: the linear search and the binary search, and then the sorting techniques. Sorting is nothing but the arranging the elements in an order, that is either ascending order or descending order. Order is nothing but the small number to bigger number, and descending order is nothing but the bigger number to smaller number. So it is bubble sort and the selection sort, the bubble sort and the selection sort. So let's find, now these are the array elements. So whenever I want to search for a particular element, I'll find the find option and I'm going to press Ctrl F. So there might be a linear search program that is running behind. Okay, how is linear search program running behind? As it is going to search for an element. Now it is, let's assume there are arrays in that particular document, then it is going to perform this particular program will be executed. Now, how is it going to be searched? First, we want to search for a number 20, right? We want to search for a number 20 in these particular array. Now, how is it going to say? Now, if I ask the person to search for a number 20, how is he going to search? He can search from right side. He can search come from this side. He can come from this side. He can come from the middle directly. It's his choice, right? So we know the algorithm how to search, but in for a computer, as it is as it cannot function on its own, we need to give the algorithm. Now, how is it going to check the algorithm? Now, there might be another. Now, as I said you in the example before, he might be searching for the alternate elements. The alternate elements he might be searching for, and then he might find. Or if he didn't find in these elements, he's going to check the next alternate elements. Next alternate elements means 50, 70, 60, and so on. So in this particular part, you need to understand, we need to give the algorithm. So here, what the algorithm for the linear search part is that it is going to define for, it is going to do it for every element. Now the element in the 0, the element in 1, the element in 2, till the element gets found by the array, it is going to search. If it is not there in 8 also, the last part of the array also, then it is going to return that the element is not available. Right. So that is about the linear search. And coming to the binary search. First, you need to understand that the binary search always works. That is the most important point. Right? What I'm saying here is the most important point. The binary search will always work in only sorted elements. Now, the elements here in the linear search, as it is going to search in all numbers, we don't need to write. See, these are the numbers here are jumbled. They're not in any particular order. Right. But in binary search, they should always be in an order. So what is this algorithm for binary search? First is first if it wants to search for the number 23. So how is it going to search for the number 23? Now there are three things that we need to remember. The three terms in the binary search. That is low, high, and mid. Now how is low, high, and mid? Low is the element with the index 0, not the element. It is with the number with the element 0. Right. That is nothing but the low. Right, that is nothing but the low. So anyway, so that is nothing but the low, and then it is matrix. So matrix is the now there are 10 elements, right? Now there are 10 elements. Okay. Now low plus high by 2. Low plus high by 2 is nothing but 9 by 2. That is fourth element, 4.5. So instead of taking 4.5, I am going to take it as fourth element. So fourth element is the middle element, and the high element is the last element. Okay. So high equal to 9. So it is going to be in the, so I want to search for the number 23. So when I want to search for the number 23, we need to understand that In the binary search algorithm, it will check. It is in the ascending order. So it will check that if the middle element is fourth element, it is going to search for the first, it is going to search for the middle element. Now the middle element here is 16. So it is going to compare 16 and 23. It is going to compare 16 and 23, which is higher. 20, 23 is higher. So obviously it is in the ascending order. So it will not be in the left side. Means these all elements are smaller than the number 16, right? So it will not be in the left element. So it is going to understand that it will be in the right part of the algorithm. It will be in the right part of the array. When it is going to be in the right part of the array, we need to understand again there will be comparisons. Now again, here there is a little black background for these five numbers because it is going to consider the number is not here. Okay, not consider the number is not, will not be over there. So it is given as the black background. Okay, so when that particular happens, when the number is not in this particular array, the L, right, that L will be added with a number, okay, with this particular part, with the right part after the middle element, whatever the number here, 4 is there now, the next element, the fifth element, right? So that particular fifth element, L will be uh, updated. So with that particular L equal to 5 and M equal to 7. Now again, we are not updating the value of H. So again, what is it going to take? Low plus high by 2, as I said before. Low plus high means 9 plus 5 is 14. 14 by 2 is 7. So you have understood, right? Now again, what is it going to check? The same way again. Now it is going to check for the middle value. Now what is the middle value? Middle value here is 56. Now it is going to compare 23 and 56. When it is going to compare 23 and 56, 56 is bigger than 23. So what will it do? It is going to check in this particular part, left part of this 23 and 38, right? So when it is going to check for 23 and 38, okay, this will be the low, this will be the high. This is what is written here. This will be the low, this will be the high. Now, you need to understand that again, middle value is nothing but low plus high by 2. Low plus high by 2 is nothing but the middle, means 5 plus 6 is 11. 11 by 2 is 5.5. 5.5 without the decimal part I'm taking it, so it will be 5. So it is going to first, what will it check? First, it is going to check for the middle value, right? If the middle value is being compared accordingly, we go to the left or the right part. Now here, what is it going to check? So it is going to check for m equal to 5. So 23 is being found. So found a 23, that is what it is going to return. So I'm going to show this part in code. So this is the linear search program, guys. So hash include stdio.h int main int a of 10, and I have defined 4 constants. I'm not typing it into diffuse so that the time will be saved and I can complete the session in just 1 hour. So then I'm the number of elements I want. So it should be always be less than 10 because I have allotted only 10 spaces. When I have allotted 10 spaces means the elements can be, I mean, the elements can be empty also. So the maximum number of elements in the array is only 10. Maximum number of elements that I'm going to define here should always be less than 10. That is a constraint over here that I'm giving it. So anyway, it should scan the n value. We have prompted it over here. We have prompted it. So once you have prompted it, we are scanning the n value. Once the scanning n value is done, enter the percentage number of elements. We can write the number of elements over there. Once you have done that part, now I'm taking the elements. Now how am I going to take the elements? Now I have said you that we are going to take the elements. Now how are we going to take the elements is nothing but I have shown you how to take the elements before, right? How to access the element, each and every element. I have shown you for in a very small example. Here also in the same way we are going to take one after the other, scan percent d and ampersand, scan percent d ampersand a of I. Right, scan percent ampersand a of I, each element will be saved over there according to the I value. I value will be incremented over here. So after one value the other, the number will be saved in the array. Once it is being saved, we are scanning the key value. Now you know what is the key value. Key value is nothing but the value that needs to be searched. So we have understood that part. Now let me slow here so that this is the new part. Now for int I equal to 0, I is less than n, I plus plus. Now there is nothing but a loop for loop. And once you have done that part, it needs to be searched one number after the other. In linear search, it should be searched one number after the other. When it is searching for one number after the other, printf, okay, if the value is same. If the value is same, then the key is found at the person d. Now the person d, the number should be always be I plus 1, because the number actually starts from 0, right? The indexing starts from 0. Now, if it is found in the third place, it is actually in the fourth place of the array according to our counting. When we count as the first element as a number 1. So, it is going to print as I plus 1. So, if the loop doesn't break in any iteration, means if the number is not found. Okay. If the loop doesn't break in any iteration, means I equal to n. Means it has reached a position where I equal to n. Then key is not found. That should be printed. So, I'm going to, it is already saved, so compiling it and running it. So enter the number of elements you want. This is the first statement that is going to be executed. So let's wait. Yeah, enter the number of elements you want. I want to give 5 elements. So the elements are 1, 2, 3, 4, and 5. Enter the key value to search. Let me search for the value 4. See, actually it should return 3. Means this is at 1, this is at 0, this is at 1, this is at 2, this is at 3. But at I equal to 3, I will get incremented plus 1 from here, and I value key is found at 4. So this is nothing but a linear search program. Now let's go to the binary search program. Now binary search program is also easy. Now as I've already said you how it works, let me go to the program hash include str.h int main. You have understood, and then I have defined low, high, and mid. I've said you already. Key is nothing but a value that needs to be searched. Okay, we are scanning the n value. You have understood this part. Scanning the array part. You have understood scanning the keyword. Now these are all the same in the linear search and the binary search. Once you get to know how to take the input, you can take this part. Now only this is the new part. I've shown you in the last two programs also. Anyways, how to take the array elements. So anyway, coming to the main logic. Okay, I have written the comment so that it is easy for me to guide from one part to the other. So low equal to 0, high equal to n minus 1. Now, as I said, as it starts from 0, indexing starts from 0. Even if there are n elements, there high is equal to n minus 1. So while low equal to less than or equal to high, see, it is always in the, as I said to you, the very first point, it should always be in the ascending order or the array, descending order, right? First, we need to remember that. Now, low is always less than high, right? So there are n elements. So that means if there is only one element in a array and there is only one space. So low is always low then less than or equal to high, right? So low is nothing but low equal to high means now high is here n equal to 1. So low high equal to 1, right? So there are only right. So you have understood that low is always greater than less than or equal to high. So once you have understood, then this particular statement I have said you in the example already. Once you have understood the statement in the line number 20, we need to understand that first it is going to check for the middle value. Now that is what I have written the condition. If a mid equal to key, then the key is found in that particular place. Mid plus 1 because it starts from 0. Now it should break the statement. That is fine because it should break the statement because it shouldn't be in this loop anyway. Because it need not to be loop in the loop when you already got the number. Right? If we didn't get the number, it should check how it should know. It should check in the left part or in the right part. So accordingly, the low value or the high value should be changed. Low value or the high value should be changed. Means this is how we are going to write. If a mid is less than key, then low equal to mid plus 1. Okay, then it will search in the right part of the array. Now if that is not, if this condition is also not being satisfied, then it will come to this part. Now in the next part, it should search in the left part of the array. So that is going to be searched high equal to mid minus 1. Right, means from the left part, from the first element to the right part, that will be saved. So if low is greater than high, there is a key is not found. Right, key is not found. Directly we can say that. Return 0. Now I'm going to compile and run it. Right. So it is first going to be asked number of elements. So the number of elements I want is, let me take 5 elements again. Okay, 5 elements. Again the same elements, 1, 2, 3, 4, 5. Okay, there should be space. 1, 2, 3, 4, 5. Enter the key value. I want to search for 4 itself. Key is found at 4 place. Okay. This is the same example as I've shown for the linear search. The only difference is that the searching technique, right? And as in the linear search, there will be more number of comparisons that should take place, which will affect the time complexity. It will take more time. And preferably here, there will be less number of comparisons. So it is better rate. So the next part that I'm going to show you is the sorting techniques. Now, as I said you, the sorting techniques, this will it is arranging the array elements in ascending or descending order. So this is the initial order. Now 5, 3, 8, 4, 6. This should be placed in right. This should be placed in a sorted way. So let us assume we want to sort it in an ascending order, right? So if we want to sort it in an ascending order, first what it is going to take in this particular algorithm, first it is going to take two elements. Now the two elements are 5 and 3, right? So it is going to swap because in the ascending order 3 is less than 5. So in the same way, again the next two elements will be compared. Now swap will take place, right? Now once the swap has been take place, 3 is the first element, 5 is the second element. Now these have no change. Right? When again 5 and 8 is compared, right? When 5 and 8 is compared, 5 is small. So there should be no swap taking place here. Right? Again 8 and 4, the next element. When it is compared 8 and 4, we need to understand that 8 is greater than 4. So 8 and 4 should take place in the ascending order. Right? So 4 should come here, 8 should go here. So that is what happened here. Okay, this goes on. Now again 8 and 6 will be compared. See two elements, one after the other. Right, 8 and 6. So 6 should come here. Now again this takes place hundred number of times until there should be no swapping taking place. If there are no swaps taking place, means it is has reached the ascending order. Means again no 6 is in this place, 8 is in this place. Now again it will start comparing. Now 5 and 4. Okay. Now 3 and 5 will be compared. It should be in this place only. When it is compared again, 5 and 4, what will take place? Again, 4 and 5 will be changed. Now 6 is here now. Now again, it is going to check 6 is here. Means 5 and 6 will take comparison. When it is going to check 5 and 6, 5 is smaller than 6. No comparison. Now again, 6 and 8. No comparison and no swap already. So it has reached. Now again, it will start from 3 and 4. Now again, it will start from 5 and 6. Again, it will start from 6 and 8. As there are no swaps and no comparisons taking place further, we need to understand that it has been the it has been done. The sorting has been done. The next part is that selection sort. The selection sort is nothing but selection sorting algorithm sorts an array by repeatedly finding the minimum number of elements from the unsorted array and putting it at the beginning. Means whatever it is going to divide the whole array into two parts, either uh, either in the part of sorted array and the unsorted array. Okay, so once it is sorted, it is going to go in the first part. Okay, now I'm going to show you in the code anyway. So the algorithm maintains two subarrays in a given array. The subarray which is already sorted and which is not unsorted. So the minimum element from the unsorted part will be putting it at the beginning. So it will be sorted. So anyway, I'm going to show you the code. Bubble sort first. Right. Bubble sort hash include stdio.h int main we have understood. Now we have understood this part, the line number 5 part. Anyway, we are scanning the n elements. Okay, we are scanning the number of elements. The same part here also, in same as linear search. The same part I have pasted it here, right? So scanning array elements, and then we don't need to take any key value here. It is sorting it. So here is the main logic. Okay, so for int I equal to 0, I is less than n minus 1. You have understood because there are n elements and it starts from 0. So it will always be less than n minus 1. So I plus plus for all the elements it should be searched. And for j equal to 0, j is less than n minus 1 and j plus plus. J minus I minus 1. So so there should be swapping taking place. So swapping, how it should take place. Now first we need to remember that equal to sign is from a precedent and associative that I shown you in the very first day, it should right to left assignment will take place. Means A to J element is nothing but a temporary value. Okay. Now let's assume if that is a temporary value. Now how it should now if J is greater than J plus I. Okay, that swap from taking place. Right. If then in that particular case, swap should take place. How the swap should take place? Now, swapping can be done in two lines or in the three lines also. Now, with using third variable and without using third variable. Here I'm using a third variable known as a temporary variable. So instead of writing temporary variable, I'm going to write it as temp. Okay. So temp equal to a of j. Now again, a of j value, I'm assigning it to a of j plus I. Means here the swap has been taking place. And again, a of j plus 1 equal to 10. So I'll just swap the values. Right. Now, just with these three elements, you can try two numbers and try them. Right. With a temporary value A and B. And again, you can try A of j plus 1 is B and A is 1. And that is the most basic element. Right. The most basic uh, program, right? You can try that part and then come to the bubble sort part so that you can understand the swapping part, right? End of the main logic, we have completed the main logic, and again we should print the array, right? We should print the array. Now, how are we going to print the array? Again, we are going to write the for loop, and then we are going to write return zero, right? So, compiling it and running it, right? So, first part number of elements. Right. I'm going to give it in the descending order first. Okay, five elements I want to take. Now five elements. I'm going to take five, four, okay, five, four, three, space two, space one. Right. After see as it's a computer, it's giving me very fast. One, two, three, four, five. Number of comparisons will take many, but the swapping will be done and it will give me the answer. One, two, three, four, five. This is nothing but the purple sorting technique. Now coming to the selection sort technique. Selection sort technique or the algorithm. Okay. Now scanning the n value, scanning the array elements. Now main logic we have understood. Now coming to the main part. Okay, here also there is a nested loop. Now coming to the nested loop here, the number of positions. Now int I equal to 0, I is less than n minus 1, I plus plus. Now you have understood this part. I have already repeated in the last part as there are n elements, then it starts from 0 in the array. So we need to first find the minimum value for the ith position. Okay, the minimum value in the ith position. Min position equal to I. For j equal to I plus 1, j is less than n, j plus plus means the nested loop here. If a equal to j is less than minimum of position, then swap, then the swapping should take place in this particular way. Right. Min position is always equal to j. Right. The swapping technique, as I said to you before, that swap will take place. Okay. Now swapping is not here. The adjacent element swapping will not take place. The elements which have to be whichever it is the least, that particular element will be swapped, and it will be one part will be in the sorted and other part will be in the unsorted. We have understood that part. So once we have done that part, printf, we are going to print the statements. Okay, now compiling it and running it. Now again I'm going to give five elements, 5, 4, 5, 4, 3, 2, 1. The sorted array is 1, 2, 3, 4, 5. The same technique I've used for these both techniques. The thing that you need to understand is that 1, 2, 3, 4, 5. The sorting has been taking place according to this part. Okay. So according to this algorithm, it has been taking place. So anyway, so the selection sort you have understood. So coming here, the strings in C. So as I said you that we are going to discuss the character array, that is nothing but a string in this part, the last part. So a string is a sequence of characters that will ended with a null character 0. Now a string, this part is most important part, is always going to end as /0. How to declare char s5? Okay, we can write it like this: char C and this particular bracket, square brackets again, and language, right? Or we can also write in this particular part without writing, we are not writing the number right here. So here that is what we are going to write. Okay, again char c equal to 50 abcd. Right. If we write abcd, we need to understand that uh, the all remaining means here I have written as only four elements I have given here. Now remaining the 46 elements will be saved as empty. Right? And in the last, as I said you, it will be this slash zero. And again star C5 A B C D. And again slash zero. We can define it like this also. So this is how it looks. As it's a string, it should be S0, S1, S2, S3, and S4. Now we are going to use the word strings itself, not a character array, right? We can use these methods. Methods are nothing but this method will give me the length of the array. This method, so uh, copy string to another, stcr cmp and strcat concatenates two strings, compares two strings. Right? Now, once we have understood this part, let's do a simple program in C. So, source file hash include stdio.h and then int main and then right, it is a character, right? So, char C square brackets. Now, I want to write there with the number of elements. Let me write uh, okay, I'm going to take 7 letters. Right. So 7. Now I'm going to give the word edspread as channel name. Right. 7 letters. So instead of taking 7 letters, I'm going to take 8 letters. One will be remaining empty. So that's fine. So in the same way, how we are going to print it for arrays, in the same way we are going to do that for I equal to 0, I plus plus. Okay, I is less than 8 and I plus plus. Printf %d percentage percentage should be used, percentage and C should be printed. So this is how we are going to write the program to print the elements in C. So see, the word edspread has been printed. So you can define many things like this. You can find the string length, right? We can find the string length and etc. You can find how to concatenate the strings and everything. So that's it for today, guys. So thank you, everyone. So let me remind you that there will be an attendance form which will be sent in the live chat at the end of the session. It will also be pasted in the description. So please don't forget to like, comment, share, and subscribe to Expert.